Hi guys, this is a second video, I believe, about Morph targets. So today we're going to jump finally into Unreal, but before doing that, let me try to explain what kind of example I'm going to go through. So this is in Maya, we have a plane, and this is our main object, and then I've modeled these two blade shapes or morph targets, so target 1 and target 2. You can see that one is called wrinkle U, and basically it's wrinkled horizontally, and another one is the wrinkled V, and the wrinkles are vertical. So the way I've done that, it's nothing complex. I simply duplicated the mesh and selected the edge loops and moved them either that way or this way. Okay, so if I apply now these two as a plane shape, I want you to have a look, because this is something I spoke about last time. Have a look at the order of deformation. First, we're calculating the plane shape and then the skin cluster. There is also skin cluster because, as you can see here, we have joints. You have these 3 joints. Okay, so first we have these two plane shape applied. We have wrinkles U, and when I manipulate it, you can see the wrinkles going down, and when we have move wrinkles V, we can see the vertical wrinkles going up. Okay, so basically we have this kind of motion and this kind of motion. After that, we have the skin cluster, which means we have some joints. We have the end joint, the mid joint, and then we have the root that moves everything. Now I baked down an animation, and this kind of animation is exactly the type, and keep in mind that this is just pure animation. There is no rig in here, so I hand animated everything in here, and this is exactly the type of effect I'm going to try to reproduce in Unreal in order to explain and go through the morph targets mechanism. So this is the animation. The joints are getting closer, and around frame 15 these 3 joints are collapsed. The middle joint has scaled out, and the plane shape has been triggered, wrinkles W. So there is some kind of compression effect. Then I'm going back to 0, and then I'm extending it. And when I'm extending it, there is another kind. The other plane shape is triggered. So wrinkles U. Check the values here. Is wrinkles U activated? Go back. Everything is at 0. Wrinkles V to 1, and then everything back at 0. 0, 1, 0. So ideally, you would want to have this kind of behavior in a rig. So all of this kind of mechanism gets triggered automatically. So why we're doing, I chose this example. This example allows me to explain a little bit about morph targets. I have 2 targets to trigger using the same control. It allows me to talk a little bit about how to trigger or remap values on a morph target, and I think it's an interesting enough for a basic example to to keep moving forward. So I exported all of this, and well, I don't need the targets. I exported all of these as an FBX, and I brought it back into Unreal. So in Unreal, I then imported it, and this is how the skeletal mesh should look like if it came in properly with the morph targets. So you should be able to see the joints, and those are fine. Though you should be able to move those, and then it should come in with these 2 attributes here. So in the morph target preview, you should have a list of targets. Now, if you don't have this, it means that you have not specified to import morph targets when you imported the skeletal mesh. How can you fix that? You simply go into the asset detail, you type morph targets, and you say import morph targets. It might be that this checkbox is off, so you trigger that on, you click reimport mesh, you close the window. Just to be safe, you can click reimport here, and then you reopen, and then you should have these 2. Always have a look if these 2 Morph targets are now enabled, and you can see that I have these two seem to work, and it seems like this is working as well. Okay, so this is basically pretty much the basics on how to bring in morph targets inside Unreal. Now I've applied a shader, and the shader, you need to make sure that if you want to have a shader, you want to make sure that the shader itself has use with morph targets on. So let's have a look at the final result. So in here I have my rig. I basically extend the rig, compress the rig, extend, compress. You can see that the rig is seamlessly blending between two morph targets, but on top of that, the skin cluster is helping the deformation. So that's why I picked this example. There is a combination of joint rigging, or bone rigging, and morph targets rigging, and you can see that by combining the two things together, you can have interesting effects. This is a basics example, but the core idea behind is it's the core idea behind any kind of facial setup, or a setup that involves both skeleton, both skin cluster deformer and blend shape / morph target deformer. Okay, so let's have a look how this is achieved. So in my rig hierarchy, I have my 3 joints. There's a middle joints in the middle. There are 2 controls. The very first thing I do, actually I don't need any of this, sorry, that's a leftover. So this to the setup event, and basically snapping the position of the first control to the root joint, and the position of the second control to the end joint. That's it for the setup event. You should be really familiar with this by now. In the forward solve, I'm simply saying the root control drives the root bone. Okay, transform. The end control drives the end bone. Okay, so the final bone. What happens in the middle? Well, I'm simply taking the the transform of the end bone and the first bone, so this one and this one, and I'm interpolating between the two of them. So I'm blending with an alpha of 5, and this value, which is interpolation of these two matrices, gets fed into the input matrix, or the transform of the middle bone. So basically the bone, it's always in the middle. So up to here, if I were to disable all of this, up to here, this is what I have. I have the end bone, start bone, following exactly those control, and the middle control in the middle. Now let's connect that back in. Here's where it becomes a little bit more interesting. So the first thing I'm doing is I'm calculating the distance between here and here. And right now I can tell you that this distance is 10. All right? So this distance, it's constantly being calculated. If I look, watch this value, I can see that the distance is 10. And if these two joints move apart, the distance gets bigger or smaller if they get close together. So really the distance, this is an arbitrary value. It shouldn't be 10 so precise. It just happens to be that in Maya I scaled up the plane by 10 units, but this can be an arbitrary distance. This value here represents our 0, or our neutral pose. All right? So what I'm saying now with these remap nodes, I'm saying that my minimum value, so my neutral value, it's 10 here and here, and my maximum value, it's 20. And every time this value is 10, I want this node to output 0. And every time this value is 20, I want this node to output 2. And what happens in between? If this value, as a result, the value inside here is interpolated. So let's watch this value. The distance is 10, I'm outputting 0. I'm increasing the distance, 12. The result it's a value between 0 and 2 has increased. Let's keep this going with this distance. Let's get close to 20 here. Let's get close to 20. You can see that this value is, you know, getting close to 2. So basically this is nothing else than remapping the value. Now what I'm doing that, because I don't, this system needs to work depending on whatever distance. Whatever distance these two control might have so this value can change. But what I want is a way to trigger the blend shape value, the Morph target value. How do you do that? By setting a curve value. Now if you go into Windows, Tools, Curve Container, you should be able to see these two curves, and these are the names of the curves that your skeletal mesh comes in. So what it means is that you can say set curve value, and in here this curve represents the amount of blend shape that gets triggered. So you can pick and choose which blend shape, and those two names are nothing else than the two names that we saw in the skeletal mesh here. Alright, so did I just close everything? Perfect. So in here, what I'm saying here, this value here is the amount of blend shape that gets triggered. So what I am really saying here is that at the origin, the value should be 0. Okay, so this value is 0 now, so nothing gets triggered. When I'm getting more, the distance is more than 10. Let me get this bit bigger for you guys. When the distance is more than 10, this value should get close to 1 or close to 2. So in this moment, I'm saying that this blend shape not only needs to be activated, but it needs to go beyond the number 1. So the wrinkles gets a little bit higher. And this is just a stylistic choice that I've made because I want this wrinkles to be a little bit more prominent. But nothing stops me to say that the maximum, I only want the actual blend shape that has been modeled. So this is the exact amount that the blend shape would get triggered. But you can see here that these wrinkles did not get high enough. I want more. So we can say that these goes up to 2. And you can see that now it feels that way. All right. So what's happening when I'm compressing is the same exact thing. But rather than saying, you can see here that here I'm going from of 10 units. So I'm saying that the minimum it's my 0, it's 10, and my top maximum it's 20. Right? And here I'm doing the opposite. So 10 units below, when 10 is my 0, when I'm at 0, I want to trigger another shape, which happens to be the wrinkles V. So this portion of the graph here takes care, let me ignore that. This portion of the graph here takes care of the extension, I'm triggering a blend shape. Compression, I'm triggering another blend shape, you see? Now you can see that by disabling the last bit, I got rid of the scale behavior. The scale behavior is very simple. I'm simply saying when it is extending, go to 20, but I want whatever value gets here at maximum of 0.5, and I'm setting that to the scale. But because this is a live node, it goes back and forth between those two values. So what happens is that when my source minimum is at its origin, the output value, if I check this value here, it's 1, meaning that the scale of the middle joint is 1, so nothing happens. The more I extend it, the scale gets smaller. Translate scale Z gets smaller, which means it's compressing and is giving the impression that it's smaller. You can see. When I'm going backwards, this is I could have used another remap node, but because this value gets smaller and I'm dividing, well, basically I'm moving between a scale factor, which means now it's outputting a bigger value. you can see that it's scaling outward. So in here I was able to say one remap value, but that doesn't really matter. So you can see that the final behavior is that. Now, again, this is a very simple example, but allows us to see how can we combine and why we have to combine joints, bones, with blend shapes / morph targets. It basically gives us the opportunity to use the two type of deformers in the most optimal way to keep things really simple and, you know, easy to manipulate. You can imagine that if I want to change the shape of this specific wrinkle, I can simply go back to Maya and remodel it, or that kind of stuff. Now, this value here is nothing else than a reader, meaning that we don't necessarily only have to trigger blend shapes with it. We can trigger normal mapping, we can trigger all sort of, or even shading. We can say when it's extending, this plane needs to go red, and when it's compressing, needs to go blue. So this area here, this thing is what I consider a reader. So this is the rule that you're creating in order to trigger this value. Okay, we're going to talk about this a little bit more in the future, but imagine this here. This is just an algorithm that I invented just to say move these values between 0 and 1 following this rule. So I don't, if instead of using blend shapes I were to use shader attributes or shader dynamic instance attributes, I could simply say when these two cubes are getting far away, shade the color blue, and when they're getting closer, shade the color red. And or texturing or normal mapping, all that kind of attributes that are inside a shader, for example. We're not touching shaders right now, but it's the same concept. I hope this makes sense. Cheers!